little bit about distributive property. If we look at the word distributive, it may make you think about the word distribute. And distribute just means to give something in a group. So now let's define distributive property. Distributive property lets you multiply a sum by multiplying each addend separately and then add the products. Example, 2 open parentheses of a minus 3 close parentheses. 2 times a, which you will going to distribute, will give you the answer of 2a. 2 times 3 or negative 3 will give you the answer of negative 6. So your final answer would be 2a minus 6. When you do the distributive property, that you're actually doing is taking a factored expression and expanding it. Remember, when you multiply variables together, you just set them together in alphabetical. So a times b will give you the answer of AB. A times C will give you the answer of AC. So your final answer would be AB plus AC. Next, I am going to go over a proof problem, but before that, let's answer first this question. How to prove distributive property using De Morgan's law? But before that, let's define first the De Morgan's law. De Morgan's law is the complement of the union of the two sets is equal to the intersection of their complements, and the complement of the intersection of the two sets is equal to the union of their complements. So given the example, open parenthesis A union B close parenthesis intersection C is equal to open parenthesis A intersection C close parenthesis union open parenthesis B intersection C close parenthesis. Now we will going to prove distributive property using De Morgan's law. Let's assume that X is an element of A, open parenthesis, A union B, close parenthesis, intersection C. Let's assume that X is an element of open parenthesis, A union B, close parenthesis, intersection C. X is an element of A union B, and X is an element also of C. This part says X is an element of A union B. That means X is either an element of A or this X is an element of B. And if X is either an element of A and B, it will definitely be there in the union. And X is an element of C. Then that means one of these conditions are true because we know X is either an element of A and B, or it can be either their input. That means either this is true, that X is an element of A and X is an element of C. This condition is true, whereas we are saying that X is an element of B and X is an element of C. One of these conditions are definitely true. Both of them can also be true. So if this is true, from here we can definitely say that X is an element of open parenthesis A intersection C close parenthesis. And from here we can say that, or X is an element of open parenthesis B intersection C close parenthesis. From here, we can say that X is either an element of open parenthesis A intersection C close parenthesis U open parenthesis B intersection C close parenthesis. So whatever may be the case, if X will definitely be there in the union of A intersection C and B intersection. Since X is an element of open parenthesis A union B close parenthesis intersection C, it will be an element of X and element of open parenthesis A intersection C close parenthesis union open parenthesis B intersection C close parenthesis. So this is the written proof of the first distributive law.